Now, for line of best fit, technically we just found that you're supposed to start about 2 and then go up 5/1. But all I really want is you to plot something that goes through. So if I was, okay, so that'd be about 2. Maybe like that. Maybe it needs to be shifted up just a little bit more. Kind of wish I had made it a little higher. Okay. There is a way to get the line of best fit on the calculator. I cannot remember how to do that. Yeah, a line of best fit. Draw the line. It doesn't have to look exactly like mine, but draw the line you think would best fit the data. I am going to say that I kind of wish I'd done this. Okay, I think this would probably fit the data a little bit more. You only need one line, okay? I'm not going to take off points because you're off by a little bit. You guys have never taken statistics. Okay, just draw a line you think goes through most of the data and has about the same number on each side. That works for me. Now, but what we could do is we could use this line to predict after 10 days. Okay? And it says use your equation. So y equals 5.31x plus 2.42. And it's asking, how many assignments do you think this guy is going to be missing after 10 days? Our x is days, y is number of missing assignments. Days, number of missing assignments. So I'm going to plug 10 in for x. $55.52. So according to my equation that the calculator was smart enough to find, which by the way, if we didn't use that, it's pretty tedious and it would take like a whole page of finding like, what's it called, variations and standard deviations. So we're lucky we have that technology. So I would say after 10 days, he will have, we don't know, maybe he is a good student and he starts turning his assignment in, but after 10 days we predict. We don't really know for sure. We predict, does the guy have a name? Nope. We predict there will be around 56 missing assignments. And I decided, let's go ahead and just round that to 56. Can't really have 55 and a half missing assignments. Now I'm curious now, if I had extended this, how good my line was. So according to my graph, 10 days, he would have about 52 missing assignments, right? On that line. And if you look at this line, extending that, after 10 days, I predicted he'd have, I don't know, way more than 60, right? I guess I could keep going. So 10 here, Here, 65, 70, it's about 80. I predicted the orange to be about 80 missing assignments. With the pink, I predicted it would be 10 days, 52 missing assignments. Okay, so actually, that pink line is close as a better line, a best fit than the orange line. Does that make sense? And the reason why the pink line, I guess that pink or red, the reason why this line fits better is because it takes into account this point that's way down here, where the orange one I tried to draw through all the data. So actually, I was correct the first time. The pink, this one, is the one I would go with. I'm not going to be picky on the test, as long as you're kind of close. Like if you had both plotted, I would probably take both. You only have to plot one. But the one that stands out more is the one I highlighted. That's the line that is closer to the equation. Does that make sense? Alright, we are almost finished. By the way, if you like this kind of stuff, there's a job out called actuary, where you get to predict stuff and do estimation, and it pays a lot of money and uses a lot of math. Do one more example. It is number of wins versus point differential. Now, I'm going to make that my x, make that my y. Looks like number of wins. 3, 1, 1, 1, 3, 2, 1, 0. Well, it's going to be kind of a boring graph, so I'll put 0, 1, 2, 3. This is number of wins. Point differential. Going from 0 to about 66, and I want to give myself probably time to estimate. If I count by tens, 10, 20, 30, 40, 50, 60, 70, that would give me this much space to work with for estimation. So I think 10 is good. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 112. Plot the points. Number of wins, 3, 66. Halfway is 65, so a little bit above half. Is 14. 1 is also 27. We already know this graph is not a function because we have the same x value on the two different y values. Remember the vertical line test? 133, 343, 220, 111, and 00. I wonder, it looks like there is a correlation. It looks like it's going to go up. I would say this has a positive correlation. Could be that there is no correlation, but I'm going to guess positive. Definitely not negative because it is going up. It does look like this. That's called a positive correlation. Right. Draw a line of best fit. Well, maybe, let's see, maybe if I make it like that, maybe. And it doesn't always have to go through 0, 0. Okay, so maybe please keep in mind that just because I drew mine like this is called an estimation. Yours could be slightly different. You go through 0, 0, maybe you start yours up a little bit higher. Maybe you get the equation and then cheat from that, okay? But we can find the equation. So we need to go to Stat, Edit, clear out those values, clear down arrow, clear down arrow, that clears out. Type in the data. It is 3, 1, 1, 1, 3, 2, 0. And for my Y, my L2, 66, 14, 27, 33, 43, 29, 11, 0. It does not hurt to double check your work. Actually, I highly encourage it. 366, yes. 114, yes. 127, yes. 133, yes. 343, yes. 229, yes. 111, yes. And then you can't see it. There should be a 0, 0. And then a common mistake I see is there's data down here at the bottom from the pre-typed in that you didn't erase, and that's going to mess up your line of best fit. So I have it in there. I'm going to go Stat, Count, and it's a linear regression. And I have, from this, the slope is 16.93. That means for every number of wins, your point differential goes up by 16.93. I have my B, my y-intercept is 2, so technically I should have started about 2 and then go up 16 over 1. If you wanted to use y equals mx plus b to graph it, you can. And my R value down here is 0.87. I would even say 0.88. That's really close to 1. So this has a pretty high correlation. Okay. My equation. So let me see. Used a graph to create a scatter plot. I did. Draw a line of best fit. I did. Write the equation. Y equals mx plus b. They use ax. A 16.94. X, my y-intercept, plus b, 2.47. Okay. What does the correlation coefficient tell you about this data? Well, the correlation coefficient is 0.88. Which shows a strong positive correlation. There's many ways to say this. I'll just stick words. By the way, I'm not doing an example, but it could be that this line goes down, which means that the correlation coefficient would be negative, and then to see how strong it is, you would see how close is it to -1. Okay. If the correlation coefficient was like 0.2, 20%, then there's not a very strong correlation. Does that make sense? But I would say 0.88, that's pretty good. Use your equation to predict the number of wins a team might have if they have a 187 point differential. Well, my equation now be careful, 180 differential, we let x be number of wins, and we let y be point differential. And you could have probably done this whole thing and let this be x and this be your y. I would suggest, you have your difference between dependent and independent variables, that you let your x always be like days or time, and then y be what you're talking about. So 187 points differential, that's actually our y. We're going to put y, 187. Okay. So don't get into a habit of always plugging in for x. You have to pay attention. Do a little math. Subtract off 247 from both sides. $184.53 equals 16.94x. Divide by 16.94 on both sides. And you get 10. You get 10.8, 16.94. So that's number of wins. Okay. So I predict the team, this is the team would have, let's round that to 11 wins with a 187 point differential. I'm curious if the line I made shows that. So 187, well, I can't use my graph because I stopped at 120. And I'm not even going to try to go up to 187. Okay? So I can't even see if my line's that great. And then it says, what do you think the run differential would be if they had 12 games? If they won 12 games? Well, I'm still going to use that same equation. Except 12 games, winning 12 games, that's my x, right? So all I gotta do is plug 12 in for x. And let's think about it. If after games, or 11 wins, they have 187, now they're asking about 12, I'm going to guess it's going to be 187 plus another 17, right? Because that's their slope for every additional win. It goes up by about 17. It'd be about 187 plus 17. So it's going to be around 2. Let's go ahead and type it in. 64 times 12 plus 2.47 is 205.75. So, winning 12 games, the team I shouldn't use like I know. I predict the team That means, maybe. I predict the team would have a point differential of around to use your calculator.